Methyl salicylate, which is the same as oil of wintergreen, is prepared by heating salicylic acid with methanol. And we're given the formula so that we can identify those species in the chemical reaction. In an experiment, 1.5 grams of salicylic acid is reacted with 11.2 grams of methanol. The yield of methyl salicylate is 1.31 grams. What is the percent yield? So we've got a lot of information given, and we also have several substances mentioned that we're going to need the molar masses for. So we're actually going to go to the next page and summarize all this information so that we can then do our calculation. So here we see our balanced chemical equation. We see the molar masses for each of our substances, as well as the amounts of each substance that was given in the problem, along with the actual yield. Now we're trying to find percent yield, which means we need to know the actual yield and the theoretical yield, and that's what we're going to have to actually calculate first. Remember that we're dealing with the amounts of two different reactants, and we don't know which one we're going to run out of first, so we have to solve this as a limiting reagent problem, which means we're going to have to do two calculations. First, we're going to assume that C7H6O3 is limiting, and that it's going to determine the maximum amount of product that can be made. So we're going to say 1.50 grams divided by our molar mass, 138.12 grams per mole. And again, I'm putting the grams on the bottom so that the units will cancel out correctly. I know that for every 1 mole of C7H6O3, I'm going to form 1 mole of C8H8O3, and I can go to the mass of that product by using the molar mass of 152.15 grams per mole of C8H8O3. So this is going to give me the maximum amount of product I can make if this first reactant, our salicylic acid, is the limiting reagent. Now I can go through and cancel out all my units. So moles of each substance, moles, moles, and I'm left with grams of my methyl salicylate, my product. And when I do the calculation, what I find is that it can produce 1.65 grams of the C8H8O3. Now I need to do a similar calculation. This time, though, I'm going to assume that our methanol, CH3OH, is the limiting reagent. And I'm going to see how much product I can make if the methanol is limiting the amount of product, or that maximum yield of product. So again, I'm going to start with the amount of methanol given, which is 11.2 grams. I'm going to use the molar mass, and again I'm going to put the grams on the bottom so that my units cancel out correctly. Then I'm going to use the coefficients from my balanced chemical equation. I see that for every 1 mole of methanol, I'm going to get 1 mole of my product, C8H8O3. And then I'm going to have to convert that back to grams. So 152.15 grams per mole of C8H8O3. Now I can go through and cancel out my units. So grams of methanol, moles of methanol, moles of methyl salicylate, and I get grams of methyl salicylate. And when I do the calculation, I see that I would get 53.3 grams of C8H8O3. So that's actually not my limiting reagent, and I know this because it produces the greater amount of product. I cannot simply look at the amount of reactants. I have to see which one is producing the least amount of product, and that substance is my limiting reagent. Now I know my limiting reagent is going to be my salicylic acid, so this is my limiting reagent, and that also tells me that this is the maximum amount I can produce. So now I know my theoretical or my maximum yield, and I can use that along with my actual yield to figure out what the percent yield is for this reaction. So now let's look at what we've got. So we have percent yield equals actual, which was given in the original problem, 1.31 grams, over our theoretical yield, which we calculated, 1.65 grams times 100. And we always want to use the smaller amount because once I run out of my salicylic acid, I can't make any more of the product regardless of how much methanol I have. So I always have to look for the one that produces the least amount of product. And now I can do the calculation, and I see that my percent yield is 79.4% yield.